Hi, welcome to Upward Bound Physics. Day 1, we're going to be talking about constant speed, buggy cars, and kinematics. So terms you need to know. First, distance is the amount of space between places or things. Displacement is the change in position of an object. And length is the measurement of an object in space in one dimension. Speed is the magnitude of the velocity. It is the travel of a distance over a period of time. Velocity is the speed of an object in a given direction. Acceleration is the rate of change of velocity. Time is an infinite continued progression of existence and events. Units for those things. Distance, displacement, and length are all going to be measured in meters, but obviously we could measure it in other things, inches and kilometers and miles and so forth, but everything will be converted into meters. Speed and velocity are going to be measured in meters per second, but again, unit conversion will be necessary. Time is measured in seconds. Again, conversions are necessary. And acceleration is standard in meters per second per second. I don't like the meters per second squared because nobody really knows what square time looks like. The variables that you will use. There can be multiple variables for a given term. Velocity is represented by v and v naught. Change in velocity is represented by delta v. Acceleration is represented by a. Distance is represented by x and x naught for horizontal motion and y naught for vertical motion. Displacement is represented by delta x and delta y, where delta x is x minus x naught. Time is represented by the letter t. Naught stands for the initial or the beginning, and delta stands for change in. The equations you need to know. The basic kinematics are, and we will look at them one at a time, simple, kinematic 1, 2, and 3. So, problem setup. You will make a chart that has terms, units, and variables. Trust me, it's the easiest way to get the information out of the problem. This list is what's given in the problem, highlight it or mark it in some way, and then fill in the rest of the chart based on what you know. So here's a sample problem. A rectangular field is 100 meters by 50 meters. A man walks the perimeter of his field in 112.2 seconds. At what velocity did he walk? So notice you're given m is meters, s is seconds, and you're given the word velocity. Filling in the rest of the chart, right? So what terms, units, and variables were represented? Those are shown in green. Filling in the rest of the chart based on what you know, we know that meters is distance or displacement, and the variables are x and x naught. Time is in seconds, letter t, and velocity is in meters per second based on what's given, and that's the letter v. So kinematic simple is for constant speed. X is your final position or the displacement from the origin in meters. X naught is the initial position, not always at the origin, so please be careful. V is the velocity in meters per second, and t is time in seconds. Kinematic 1 is v is equal to v naught plus at. You're going to use this to find velocity or acceleration or time. So v is the final velocity in meters per second, v naught is the initial velocity in meters per second, a is the acceleration in meters per second, and t is time in seconds. Kinematic 2 is x is equal to x naught plus v naught t plus 1/2 at squared. You're going to use this when talking about position, initial velocity, time, and acceleration. So x is the final position, the displacement from the origin, x naught is the initial position, v naught is the initial velocity, time is in seconds, and a is the acceleration. Finally, kinematic 3 is v squared is equal to v naught squared plus 2a delta x, or x minus x naught, where v is the final velocity, v naught is the initial velocity, a is the acceleration, x is the final position, and x naught is the initial position, or you could simply use delta x as being the displacement or the change in position. So here's our multi-step problem approach. You have to be able to write the problem, do a TÜV chart, solve the problem, that's the EWA, equation work answer units, do a data table, an xt graph, an x equals equation, a vt graph, v equals equation, and then once we actually solve using acceleration, you're going to have an at graph and an a equals equation. So having a complete TÜV chart is almost always step one, especially if you're given a written problem. So this would be a complete TÜV chart to start any problem that you have. EWA stands for the equation, and you'll either need to write the kinematic or solve the equation, rewriting the kinematic to evaluate the equation. So if you can solve a two-step equation or evaluate a two-step equation, same thing, solving versus evaluating. A data table will be position time data, and it has to contain at least 5 points. An xt graph will look like this. It's in quadrant 1 only because things can only go forward in time. They can't go backwards. An xt graph, it has to have 4 parts. You need to label the axis with the units. You need to have scales, that's what you're going to count by. It needs a title of some sort, and it needs points. You can draw a line of best fit if you want to, but it's not required. The x equals equation is either going to be kinematic simple or kinematic 2. Those are the only two x equals equations that we have. If the graph is linear, it'll be kinematic simple, x is equal to x naught plus vt, where you will replace the x naught and the v. If the graph is not linear, then it will be kinematic 2, where you'll replace the x naught, v naught, and a. The VT graph looks like this, encompassing quadrants 1 and 4 if you're thinking about math, because velocity could be positive or negative, and it needs 3 parts to its graph: an axis label with units, scales, what you're going to count by, and points, or a line. Title is not needed because the VT graph is going to go with the XT graph. The V equals equation will be kinematic 1 since that's the only V equals equation that we have. If the XT graph is linear, V equals will be a number. No units are used when you write an equation. If the graph is not linear, it will be kinematic 1, where you will have to replace V naught and A. Graphs in general, they're used to show or diagram information visually. XT is a position time graph, shows the object's location relative to the origin at any given time. The VT or velocity time graph shows the velocity at any given time. And when you put the two of them together, you can look at both position and velocity. So XT graphs, X is the vertical dependent axis, T is the horizontal independent axis, and the origin, the corner, is always going to be 0, 0. There are no breaks here, so a scale is important. On the VT graph, the V is your vertical or dependent axis, the T is your horizontal or independent axis, and it will match the it will match the time scale from the XT graph. The origin here is also always 0, 0. Again, there are no breaks, so scale is important. The equation that you need for today only is kinematic simple. X is equal to x naught plus vt, where x is the object's final position, x naught is the initial position and the vertical intercept, v is the object's velocity, and it will also be the slope of the line, and t is the time that you used or found measured in seconds. Graphs are more than just representations. The slope of an XT graph is equal to the velocity. The area of a VT graph is equal to the displacement. Given any part of a multi-step process, you should be able to complete the other parts as requested. You're going to be doing problems in class along with a lab. Thanks for watching.